Press the bell icon on the YouTube app and never miss another update.
Next, different types of sets. Types of sets. Namely, number one, first, empty set. Empty set. Later, finite set. Finite set. Next, infinite set. Infinite set. Later, singleton set. Singleton set. Later, equal and equivalent. Sets. So, first we are going to learn these different kinds of sets. First, empty set. Empty set means a set having no elements, means a set which consists of zero number of elements, means capital A is equal to the set of X such that X belongs to capital R, comma, X square plus 1, that is equal to 0. So let us consider this set. Actually, what is saying, X is real number, but the equation is R, X should be satisfied by the equation X square plus 1 equal to 0. Let us come to solve the equation. X square plus 1, that is equal to 0. That implies X square is equal to minus 1. In mathematics, square of any number should not be negative, or it can be X equal to plus or minus root of minus 1. So therefore, this value is not defined, So therefore, there are no such X which is belongs to capital R. Capital R means real number set. So that X square plus 1 is equal to 0. Means there is no any real number, so that X square plus 1 equal to 0. So therefore, capital A is empty set. Capital A is empty set. Generally, empty set is represented by or denoted by 5, just like that. Or like that. Empty set. Just you maintain the bracket. Don't write anything. These are the notations. So this is a empty set. 1 minute. Note. So the set of 5. It is not empty set. It's not empty set because this is the set which contain the element 5. Means 5 is act as an element set. Therefore, the set of 5 is not an empty set. Similarly, the set of 0, it is not empty set, an empty set, because this set contains one element 0. Therefore, it is not an empty set. So we can give different kinds of examples for empty set. So example, X square plus 1 equal to 0. You can make different kinds of examples. Okay, it is over. Next, finite set. Finite set means in the title itself the concept is there. Finite set means a set which contains a finite number of elements is called a finite set. Example, capital capital C is equal to the set of X such that X belongs to capital R real number set, comma, X square minus 5X plus 6 that is equal to 0. Actually, X C contains this kind of elements. X is what he said R, means it is in at present set builder form. Now, so that the condition is X square minus 5X plus 6 equal to 0. In earlier classes, you did know very well how to solve the equations or how to find the roots or solutions of this equation. By using factorization, we can solve this equation. Here, X square minus 5X plus 6 that is equal to 0. So, X square means 1 into X square. 1 into 6. 1 into 6 equal to 6. On product, on multiplication, we must get plus 6. Next, on addition, minus 5. We must obtain minus 5. What are they? 3 2s are. So, minus 3 comma minus 2. On multiplication, we are getting 6. On addition, we are getting minus 5. Minus 3 plus minus 2 is equal to minus 5. So, therefore, it can be splitting as minus 3x minus 2x plus 6 that is equal to, that implies x into x minus 3 minus 2 into x minus 3 that is equal to 0. So that implies x minus 3 into x minus 2 that is equal to 0. Already you are familiar with finding the factors or solutions for quadratic equation. So that implies x minus 2 is equal to 0 and x minus 3 that is equal to 0. Therefore, x is equal to 2 comma 3. Here, therefore, capital C, the set is equal the set of 2 comma 3. Of course, it is a set builder form and this one is a roster form. So, this set means n of C, cardinal number of the set capital C is 2 elements are there, 2. It is a finite number. It is a finite number or finite value. So, therefore, capital C is a finite set. Thus, a set which consists of finite number of elements means cardinal number is finite, then it is said to be finite set. Later, infinite set. Next definition, infinite set. Infinite, you come here. Infinite set means, for example, already we did know, very familiar with natural number set. Natural number set means, what is the definition? Natural number means counting numbers. So, counting numbers will starting with 1, 2, 3, 4, 5, 6, 7, 8 and so on, like that. So, it represented by capital N. Capital N stands for natural number set and so on stands for, it is read as and so on. And so on means infinite numbers are there. Infinite numbers are there. It is the concept for infinite. Okay. So therefore, if the given set contains infinite number of elements, then it is said to be infinite set. Next, singleton set. Singleton set means single, means only one. So, for example, capital A is equal to the set of 1. This set will contains only one element. Therefore, it is called singleton set. Therefore, it is called singleton set. Singleton set. Similarly, we can establish so many singleton set. -1, the set of -1. The set of 5, it is also singleton set, and the set of 0, the set of 5, the set of 100, like that. So all these are singleton sets. Next, another important definition is equal and equivalent sets. Understand? Equal and equivalent sets. First, equal sets. Equal sets. Equal sets. Equal sets means definition. The set capital A comma capital B are non-empty sets, non-empty sets, and every element of A is an element of B, and every element of B is an element of A. Then A and B are said to be equal, and it is denoted by A is equal to B, like that. Example, capital A is equal the set of 1, 2, 3, and capital B is equal to the set of 3, 1, 2. Here 1 belongs to capital A implies 1 is also belongs to capital B. Next 2 that belongs to capital A implies 2 is also belongs to capital B. Next 3 is belongs to capital A. 3 is also belongs to capital B. Over, and that to be n of A is equal to n of B. N of A equal to, it is to be understood. Whenever every element of A is in capital B and every element of B is in capital A, automatically it happens n of A equal to n of B. Then therefore we can say that A is equal to B. Actually in roster form order not necessary and repetition not necessary. We can take or we can take capital B is equal to the set of 3, 1, 1, 2, like that. Capital A, capital B, like that. Okay. So therefore n of A is equal to n of B, and each and every element of capital A is the element of capital B. Then we can say that A comma B are next equivalent sets. Equivalent means only n of A is equal to n of B. Then A comma B are said to be equivalent sets. It is denoted by capital A, like that. It is the notation for equivalent. A is equivalent to capital B, not is equal. Is equal different, equivalent different. So example, capital A is equal to the set of 1, 2, 3, and capital B is equal to the set of XYZ. Here donkeys are there, here horses are there, means numbers are there, alphabet are there. So it is different. One belongs to capital A, but one not belongs to capital B. So different. A and B will have the different kinds of elements. Okay, but n of A cardinal number of elements in capital A is 3. That is also n of B. So therefore, these are called equivalent sets. Remember, equal sets are equivalent equivalent sets means all equal sets are equivalent sets, but all equivalent sets are not equal because in equality of two sets this condition is satisfied, n of a equal to n of b. Therefore all equal sets are equivalent sets, but all equivalent sets are not equal because elements are different. This is the difference between equal and equivalent sets. Over. Next, exercise 1.2. First question. Which of the following are examples of the null set? Set of odd natural numbers divisible by 2. Actually, number 1. Set of odd natural numbers means 1, 3, 5, 7, 9, like that. Okay. Is 1 divisible by 2? No. 3? Is 3 divisible by 2? No. Is 5 divisible by 2? No. So, no number is there which is divisible by 2. So, therefore, this is null set. This is null set. So, odd natural number cannot be divisible by 2. Remember. Next, number 2. Set of even prime numbers. Prime number, already I said in the previous class the definition of the prime number. Prime numbers is starting from 2. 2 is a prime number, 3 is a prime number, 4, 5 is prime number, 6, 7, 8, 9, 10, 11. 11 is a prime number, just like that. He said set of even prime numbers, out of which these are the prime number set. These are the prime number set, the set of prime numbers. So the set of even prime number means simply number 2. Simply the set of out of which 2 is the only even number. So it is not equal to 5, null set. Next, set of even. Okay. Next, x belongs to natural number and x is less than 5, and you must consider the phrase or sentence and means your x should be satisfied by the two conditions. Means x should be a natural number and x should be less than 5 and x should be greater than 7. 1 minute. For example, x belongs to natural number and x is less than 5. Then x can be taken as 1, 2, 3, 4. That's all. For example, x belongs to natural number, x is greater than 7 means x can be taken as 8, 9, 10, 11, just like that. Infinite numbers are there. But in this question, and one phrase is there, and means it should be satisfied by both. And means both. It should be satisfied by both conditions. Both conditions means common elements. No common elements. Therefore, it is also null set. It is also null set. Next, number 4. Why is a point common to any parallel lines? Parallel lines means, for example, this is one line, L1. Next, it is L2. So, therefore, L1 line is parallel to L2. Therefore, parallel lines never intersect. Parallel lines never intersect, never intersect. Therefore, no common point. There is no common point or no common solution. No common solution. So therefore, it is also null set. It is also null set, means 5. Hence the question. State whether each of the following set is finite or infinite. Number 1. The set of lines which are parallel to the x-axis. So, explanation for first question. This is the x-axis and y-axis. Of course, it is origin. The lines which are parallel to the x-axis. Parallel to the x-axis means we can draw like that. This line is parallel to x-axis. It is also parallel to x-axis. Parallel to x-axis. So we can draw infinite lines like that. It is also parallel to x-axis. Parallel to x-axis like that. We can draw infinite parallel lines to x-axis. So therefore, it is infinite set. It is infinite set. It is infinite set. Next, the set of numbers which are multiple of 5. Multiple of 5. So question number 3. Multiple of 5 means 5. 5 1 is 5. 5 2 is 10. 5 3 is 15. 5 4 is 20. 5 5 is 25. Like that. So infinite numbers are there. Already I said in mathematics, dot stands for and so on. And so on stands for infinite. So this is infinite set. So this is an infinite set. Infinite set. Next, next number 4. The set of animals living on the earth. Actually, the number of next question number 4. The number of animals. The number of animals on the earth. And the earth. It is approximately equal to 8.7 millions. 8.7 millions. So therefore, it is a finite set. 8.7 millions is a finite number. Therefore, it is a finite set. Next, number 5. Number 5. The set of circles which passing through origin. So it seems to be finite set. No, it is not finite. Here, this is the circle. Which passing through origin. This is the graphical meaning. Means on the closed curve. Just you represent one dot. Points are represented by the dot. Its name is O, origin. So passing through origin means we can draw another circle. This is another circle. Next, we can draw like that. Next, we can draw like that. Similarly, we can draw number of means infinite number of circles which are passing through or passes through the origin. So therefore, answer is infinite. It is an infinite set. Infinite set. In these questions, we are learning that the parallel lines which are parallel to the x-axis. The lines parallel to x-axis. How can we draw? We are learning here. And how many parallel lines will be there to x-axis? We are learning here. Next, in this question, we are learning how to write the roster form of multiples of 5. Multiple of 5 means 5 into 1, 5 into 2, 5 into 3, 5 into 4. These are multiples of 5s. Okay, next. Number of animals means it is some approximation value. I obtained this value from the Google. You can also refer it. Okay, next geometrical question. How many circles can be drawn which passing through the origin? Means infinite circles are there which passing through origin. So passing through origin we can draw infinitely like that. It is geometrical question, hence the problem. Next question. In the following, state whether A is equal to B or not. A equal to 4, 8, 12, 16. B is equal to 8, 4. Okay. 4, 8, 4, 8 is there. 16 is there. But 12 is different from 18. So therefore, even if n of A equal to n of B, but 12 belongs to capital A, but 12 is not belongs to capital B. So therefore, number 2. Final answer, A not equal to B, because even if n of A means 1, 2, 3, 4, 1, 2, 3, 4, 4 elements. Even if n of A equal to n of B, comma 12, that is belongs to capital A, but 12 is not belongs to capital B. This is the reason. Of course, 18 belongs to capital B and 18 belongs to capital B, but 18 does not belongs to capital A. This is the reason for saying A not equal to B. Next, over. Next, A equal to number 3. A equal to the set of 2, 4, 6, 8, 10 and capital B. Actually here capital B given as a set builder form. X is positive even integer and X is less than or equal to 10. So even integer positive means actually 0 is also an even number, remember, but he said positive means greater than 0. So therefore 2, 4, 6, 8 is equal is there. Therefore it is included 10. So X less than or equal to 10. X or equal to X equal to 10. It can be taken 10. So therefore 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. So clearly A is equal to B. Because reason n of A because n of A equal to n of B and every element of A is an element of B and every element of B is an element of A. Therefore, A is equal to B. Next, it is over. Next, fourth one. X is multiple of 10. So, capital A. Number 4. Capital A is equal to the set of X is multiple of 10. Multiple of 10 means we can start with 10, 20, 30, 40, 50, like that. These are positive multiples of 10. Next, here 15 different element is there. Of course, capital A is an infinite set and capital B is also infinite set. But capital B given as 10, 15, 20, 25, 30, like that. So simple reason, A inference, A not equal to B because 15 15 belongs to capital B, but 15 does not belongs to capital A. Simple reason. We need not show more than this. Means we can write 25 belongs to capital B, but 25 does not belongs to capital A. It is enough to write only 1 point, so that it is A not equal to B. Hence the problem.